All right, so you got the day 9 homework to do. After we finish going over this, we'll pause for 2 minutes for you to be able to check your answers, and then we'll go through each of them. All right, in 76, f of a does exist because there's an actual point there. From 0 to a, but not inclusive, the function is defined. There's values everywhere. Not continuous at a, that's a true statement. We're looking for false. The limit of our original function f is existing. It's approaching whatever y value that is from both sides. But the derivative limit is not existing because from the left it's some positive value and from the right it's some negative value for those slopes. So therefore, that one is not true. In 77, if we want third derivative, we want to look to the third degree coefficient. So that -5 should be after we've simplified the third derivative over 3 factorial. So multiply the 3 factorial over, which is 6, and we get the third derivative is -30. 78 is a related rate, so start with your area of a circle. You got your derivative with respect to time. They told us the circumference was 20 pi, so set that equal to 2 pi r to get the radius is 10. We'll fill that in. And then we had 0.2 positive because it was increasing, and that eventually gave us the 4 pi meters per second, meters squared per second, which was choice C. In 79, we've got a chain rule when you do the derivative. So derivative of f, keep g the same, then multiply by the derivative of g afterward. Fill in your ones, and then you're just picking out everything from the table, and eventually you get choice D, which is 10. So this, we're just basically seeing how many accumulated crops have been destroyed. So you're just doing an integral from 7 to 14, putting it in the calculator, you get choice A. In 81, the limit of our function is the same as the function of our limit. So we can do the limit of f of x as x approaches 1, which would be 2, and then just do sine of 2, but then the calculator makes sure in radian mode, and we get choice A. In 82, first we want to graph r of t. We want to see where it is negative, because that would mean the altitude is decreasing when the rate function is negative. And then on that interval, we would then just do the integral of our rate function, and that would tell us the change in the altitude. 83, we're working with Rolle's theorem because at 0 and 4, they have the same y value. We're continuous and differentiable. So that means we're guaranteed the derivative equals 0 at some point. So choice E for that one. Speed, you take your derivative of your x and y components, sub in the value you want, and take the square root. So we subbed in our 3 for t after we took the derivative of each part, took the square root, and ended up with choice C. In 85, if we want an over approximation for trapezoid, but under for right-hand Riemann sum, to be trapezoid over approximation, we want it to be concave down. So, for example, here's an example of a trapezoid. I didn't draw my trapezoid very well. When we connect the points, there would be an over approximation. So we want any, and I think I might have said concave down a second ago, but we want concave up. So any of the ones that are not concave up can be ruled out. And then we want a right hand to be an under approximation. So in the two remaining, just draw in a right hand rectangle. So notice that one's under, that one's over. So that's why we want choice A. In 86, start out graph f prime, and we want to see how many times it changes signs. And make sure we're only looking on the interval from negative 1.8 to 1.8, so you probably want to switch your values on the x-axis so you're focusing in only there. In 87, start out by graphing v of t, and we want to find, using our calculator, the first zero that's right of x equals 0, so the first positive 0. And then we'll do an accumulation function. We've got to have the 3 out front, because that's where we are, we're at t equals 0, and then the integral from 0 to that value that we found, and that ends up giving us choice C. So this setup is average value of a function. Out front we'll have 1 over 2. Multiply both sides by 2, and then it'll just be our integral is equal to 2. So really we just want to see which of these will have an area of 2 on the interval from 2 to 4. And in C, each of these are 1 by 2 triangles, so they'd have areas of 1. So when you put them together, you'd get an area of 2. So choice C. In 89, so your graph is looking something like this. You're slicing perpendicular. Here's your equilateral triangle, and those blue marks match up. So that blue is really a y. So that means each of these are half a y. This equilateral, this is 60, this is 30. So your across from 60 is always square root of 3 times whatever's across from 30. So we'd get square root of 3 over 2y here. So really we got 1/2 because of the half in the triangle. Now our base all the way across is a full y, and then times the height, which was square root of 3 over 2y. So I just neaten that up here, and I have the 1/2, I have square root of 3 over 2, and then this is really y squared. Well, y was our function that they gave us, the 2x minus x squared. And then we're on the integral from 0 to 2, because that's where it was bounded by the x-axis. And then it would be in choice D. In 90, notice all the way until 2, our area under the graph is positive, so that's accumulating new positive area. So f of 1, we would have added a bunch of area from f of 0, so therefore f of 1 should be bigger, so that rules out choice 1. F of 2 should be bigger than f of 1 because we added on a lot of new positive area. But then f of 1, when we're here, we added a lot of new positive, and we only took a little bit of negative area away. So f of 3 should still be bigger than f of 1, so that's why it's just 2 only, choice B. In 91, take the derivative, get your velocity function, do menu analyze graph maximum to find the value of t where it's at its maximum, sub that back into the height equation, and you end up getting choice B. And the last one, 92, this is mean value theorem. Instantaneous rate of change is just our derivative, which we get here. Remember, derivative of natural log is 1 over stuff times d stuff, so 1 over x times 1. And then over on the left, you have your average rate of change. So it's f of 4, so in other words, 4 plus natural log 4, minus, in parentheses, 1 plus natural log 1 over 4 minus 1. And when you go through and solve that, you'll eventually get choice C. Now going to the free response, we wanted what value of k will make the slope of the tangent line, so in other words, the derivative, equal to 6. You could either do a quotient rule there, or I thought of it as all raised to the -1 and just did a chain rule. So here I did my chain rule, brought that back down, set it equal to 6. We said when x equals 0, so eventually you just get 6 equals 2 over k squared. Go through and solve, and you get k equals square root of 3 over 3, and we didn't have to worry about the plus minus because they told us k is greater than 0. Part B, they told us k is -8, so we get that integral. Well, that factors, and we can do partial fractions into x minus 4x plus 2. Eventually we'll get this, and we'll pick our strategic values of x to find a and b. I chose to pull my 1/6 out front, so I didn't have to worry about it. We didn't have any corrections when we did our natural logs because they had coefficients of 1. And then just sub in your 1s and your 0s, and eventually neatens up to negative natural log of 2 over 6. Now, it would be okay also if you just left it. This is equivalent to negative natural log of 4 minus natural log of 2 all over 6. That's the same thing. I just used my log laws that when you subtract, you divide the insides to get that that's natural log of 2. But anything that's equivalent would be fine. Now, when k is 1, that factors in x minus 1 and x minus 1. So we're actually going to have an asymptote at 1. So they kind of give you a hint that there's going to be an issue by saying if it's converging or diverging. So we have to do this separately, an integral from 0 to 1 and 1 to 2. We'll then have to do our limits. We'll do b approaches 1 from the left. We'll do a approaches 1 from the right. This is really x minus 1 to the negative 2. Technically, there's a u substitution, but there wouldn't be any correction. So that's where I'm getting the negative 1 over x minus 1 from. Sub in your b's, your numbers, and your a's. This denominator, as b goes to 1 from the left, is going to be a tiny negative. So keep change flip with the negative number will make it a big infinity. The a, when you go 1 from the right, will make it a tiny positive on bottom. So keep change flip with the one that was on top. That'll make that an infinity. So it's going to diverge because we have infinities in there. Next one, we can pick out our function value just from the graph of the curve was 3. Then the slope of the tangent line was negative 2. So that's our coefficient of the x. Then for our table, we can get our other derivatives. So second derivative is 3 over 2 factorial. Third derivative, negative 23 over 2 over 3 factorial. You can leave it as that or neaten it up in the bottom line. They wanted us to take the e to the x, which I did out to second degree, and multiply that with our answer from the previous one to get a second degree term. So from our previous one, I only wrote it out to the x squared because the x cubed is going to end up getting cut off anyway because our answer we only want to the x squared. You could have kept the x cubed and then just omitted that, but it would have led to more multiplying. And eventually it neatens up to that 3 plus x squared. So we wanted to do when x was 1. So from part A, we took our polynomial, just do the antiderivative, sub in 1. And we eventually got 97/48. And all the wording that they told us in part D was basically telling us that we could do alternating series error bound. So you had to use the piece of information we hadn't used yet, the fourth derivative over fourth factorial, and then x to the fourth. So this is our next term. Sub in the 1, we get 0.45. So that shows that's our maximum error. So that shows that our error is going to be less than or equal to that. So we're guaranteed that we differ by at most the 0.45. With the time left in the period, you can work on your homework problems and help each other out if you get stuck on those.